Hi, I'm Thomas Tooke.
And I'm David McCrystal, and this is a comparison of wire EDM cutting to conventional saw cutting.
First of all, a little overview of wire EDM cutting versus conventional saw cutting. Wire electrical discharge machining, or EDM cutting, is a non-contact process for cutting material using a very, very thin electrically charged wire and a fluid to cut metal parts by actually melting the part ahead of the wire instead of physically contacting the material and cutting it like a conventional saw might. This works with a negative terminal being connected to the wire and a positive terminal connected to the conductive material, which allows an electrical field to form in the gap between the wire and the material. And what this does is it creates sparks actually and kind of vaporizes the intended area to cut, leaving a nice clean finish and a very smooth cut. Also, it can be automated with a CNC system to control the wire and the X, Y, and Z directions to move it around, kind of in a similar way of a bandsaw or another CNC automated machine, which allows a very precise process for complex geometry and doesn't require humans to operate it full time. Conventional saw cutting, as you know, just utilizes a metal saw blade to cut through the material in a contacted fashion, which is very different from the EDM cutting process.
So here's a diagram of a wire EDM cutting machine so that we can better visualize what was just discussed. So as seen here, a workpiece is placed down on the machine bed and a wire will be running continuously through the part to make the cut. In the top right, you can see a close-up of a bird's eye view here where the wire is going through the part in a slot and there's actually a spark gap where, as mentioned, the wire never fully touches the material being cut and the sparks are doing the work in vaporizing the material. Then on the left side of the diagram, you will see that deionized water is flowing over the material as it is being cut. This helps with the cutting process and additionally will clean up any chip formation that occurs.
The advantages of wire EDM cutting, the main advantage actually is it's very precise and can cut with minimal material loss. It has a very smooth finish, which doesn't require much machining after, and a very fine tolerance. So as you can see in the picture on the bottom left, a part with a very complex geometry that a traditional saw wouldn't really be able to do. Not only can the wire do it, but it can do it without taking away much excess material. You can see how perfectly it cuts it out of that block of metal. And in the bottom right, this kind of sample puzzle piece shows how the pieces can fit perfectly together when cut by the wire EDM with very little tolerance or lost material between them. So it's a very precise cut. Traditional saw cutting by comparison is more susceptible to bowing and bending, making rougher cuts, taking away way more material than a wire would. So it's a lot less precise, kind of waste material as well. Also with wire EDM cutting, there's low tool wear since the wire melts the material ahead of it and doesn't actually touch it. There's still some wear to the wire over time, as any material would have, but a lot less than a traditional saw, which might get dulled or ground down by its contact with the material that it's cutting.
In terms of limitations of wire EDM cutting, the main drawback is that the material being cut needs to be conductive for wire EDM to occur. So non-conductive materials such as plastics and composites will not be able to be cut by wire EDM, and conventional saw cutting will need to be used. Additionally, wire EDM cutting is a relatively slow process with slow production output. The thicker the area of a material, the slower the wire must move to be able to make the clean cut desired. So for cutting things faster, traditional saw cutting might be better and cheaper to use. Additionally, wire EDM cutting requires a high electrical power to run, so this may affect operating costs, and because it can require up to 10 times as much electrical power as traditional saw cutting.
So discussing the cost specifically of the wire EDM cutting versus conventional saw cutting. Wire EDM cutting has a much higher upfront cost because the machines used for that, especially the automated ones, can be very expensive, especially compared to conventional saw cutting. But it can save time. It can make a very precise cut where a rougher saw might require more machining, polishing afterwards to finish it, where a EDM wire might just do it first try with a very clean finish. So the economical choice kind of depends on production quantity. If you were making just one part, you wouldn't put all the upfront costs in a wire EDM machine if a cheaper saw can just do the job. But if you're making a lot of parts, the investment in the wire EDM machine might be worth it because then there's lower cost for replacements and for wear on the machine as you go, which is in the long run cheaper for a variety or a high quantity of production of parts. The price for a wire EDM machine can range from a few $1,000s, 10, 15,000 on the lower end, up to even hundreds of thousands of dollars, depending on the size of the machine and the brand that you're buying. So it is a lot of dependence on what you're cutting and how much you're cutting that would kind of affect the decision of a wire EDM cutting versus saw.
Now let's make some comparisons of wire EDM cutting to saw cutting. Wire EDM cutting, in terms of chip formation, will produce very, very small chips due to the vaporization process, and these are then immediately cleaned up by the deionized water. So there's no immediate cleanup that needs to happen. Comparing to conventional saw cutting, which will have much larger chips formed, and these will potentially go all over what machine you're using and will require cleanup. Then in terms of the materials that you can cut, wire EDM cutting will be very effective on brittle and delicate materials because no force is being generated between the parts due to the non-contact nature of the cutting. So wire EDM cutting allows for very intricate and thin designs to be possible. Meanwhile, conventional saw cutting, very thin designs may not be possible, but it may be better for rougher and larger cuts that need to happen faster or cheaper. Some more comparisons to be made are that wire EDM cutting can cut very hard metals and very thick pieces that saw cutting may not be able to. However, it does have limitations on the size of the wire EDM machine, and very tall pieces may not be possible. Another thing is that wire EDM must continually run through the full contour path and cut all the way through a piece, similar to a bandsaw. So certain complex 3D shapes may require multiple setups to accomplish, and anything with a varying depth of cut may be better and easier to do with traditional saw cutting.
Taking a look at the manufacturing readiness level assessment for wire EDM cutting, we gave it a readiness level of 9, which the document states is a low rate production demonstrated and capability in place to begin full rate production. Wire EDM cutting has been developed for decades. It was started, there was wire EDM machines with CNC capabilities even back in the 70s. So it's been around for decades, and it's something that's been automated, well established, and improved over time. Specifically, it's a mature enough process to use in many production environments, and we believe that is a mature enough and a good enough process to use in our production environment at our facility, and that due to the advantages discussed earlier in this presentation, it would be an optimal choice for our manufacturing processes. It's farther along in production improvement than a readiness level of 8 would suggest, but it's not quite established, widespread, or integrated enough to reach level 10 like some processes might be that have been around for a long time. And for our production facility, we believe this would be a mature and well-made process. Looking at sources that we use today in this presentation, a lot of them were related to or from companies who sell wire EDM cutting equipment. So there is a bias that exists as they might be advocating for this process to try to sell more of their equipment or kind of putting down other processes to fight competitors with altering equipment. So any source could, even if not obviously, have bias influenced by financial gain, promoting the business, discouraging support for a competitor. It's important to consider many sources when evaluating a process like this and cross-reference information, which we did a lot with a variety of sources to form the most complete possible analysis. Here's the sources we had for this project. A lot of these are from companies that sell this equipment, so it's important to have a lot of sources, as you see here, to kind of cross-reference and have the most perfect understanding possible of the process. Thank you. I'm Thomas Tooke.
And I'm David McCrystal.